Liz, what is, looking at number 2, what's the smallest angle?
P.
P. Wait, P?
No, R.
R.
Sorry.
Which angle is across from the smallest side? Q. So the smallest angle should be actually Q. Angle Q is across from 5.9. And so that is your smallest angle, has to be directly across from it. So after Q, Megan, what's the next one?
P.
Then we got P. Across from 6.1. And so the last one, the largest angle, is angle R, the one that's across from the largest side, which is 6.8. Okay, now we'll do the sides. Aiden, what's the shortest side?
RS.
We want the side that's across from the shortest angle, not next to it. Think about the door opening. Which?
ST.
ST. So across from the shortest angle, or the smallest angle, is ST. The next one would be what, Aubrey? SR is across from 30. And then TR would be the last one. So I think there's some confusion. Look again at the picture at the top. Think about the door. The angle was across, directly across from the side that it's connected to. So notice how these are opposite. Largest angle, longest side, across from each other. Smallest angle, shortest side. Okay. Now, this is the part that I like. We're going to do some demonstration on the triangle inequality theorem. Triangle has side lengths of 10 and 6. What are all the possible lengths of the third side? We know that two sides always have to add up to be longer than the third. So I find that this is actually a pretty helpful way to do it. Let's split it up. I'm going to call our third side x. So first we'll do x as a small side, so a small x. And we'll also do x as a large side, large x. And I also think it's helpful to draw some pictures. So let's say, here's my triangle. I'm going to make the longest side on this one 26, and then x and 10. We're not necessarily saying that x has to be the smallest side, but we are saying it's got to be smaller than 26. Okay? And then the other one, because this is another possibility, is that x is the longest side. Oh, sorry. Like this. So x could be the longest, and then this would be 26, and this would be 10. So you have two kind of possibilities here. X is longer, x is shorter. You're going to write some actual inequalities. We know that two sides always have to be greater than, when I sum the two sides, have to be greater than the third. So when I add 10 and x, it has to be greater than 1. 26. Otherwise, you're either going to have a line, or it's not even going to be close to connected. So let's solve this. Subtract your 10. And voila, x has to be greater than 16, that's for sure. Otherwise, it doesn't work as a triangle. But you have another possibility, because these are like two options. 26 plus 10 has to be greater than x. So x would have to be smaller than 36 for that to work. We're going to write this as a compound inequality, because both of these things have to be true in order for x, the third side, to work. X would have to be between had to be greater than 16 and less than 36. So it's saying it's between 16 and 36. And someone asked a good question in my last hour. They're like, well, couldn't we just say the side lengths are between 17 and 35? Can we say that? Why can't you say side lengths starting at 17, ending at 35? Yeah, you can do decimals, you can do fractions. So this is continuous. It's anything, literally anything. 16.11 counts as a side, so you could have anything between there. Okay, now we're going to do one more together, and you're going to finish up the last two on your own. Decide whether you can construct a triangle with the given side lengths. 4, 9, and 10. We're going to write 3 inequalities because any two sides, when I sum them together, always has to be greater than the third. 4 plus 9 has to be greater than 10, is it? Yes, 13. 4 plus 10 has to be greater than 9, is it? Yes. And then, obviously, 10 plus 9 will be greater than 4. So is this a triangle? Yep. And we can even draw one. Hooray. Can you please work on the next two? Decide, can those be triangles? Make sure you can explain it to me. We'll start writing some inequalities, add up two sides, see if it would be greater than the third. If it's not, then it can't be a triangle.
Is Zane here today?
Yeah.
Zane. You leave yourself.
Alex, does the second to number 6, does that one work?
No,
Why not?
because this 8 is not 18, it's 17.
Right. And it's not greater than 18. It's less than, because it's 17, so this is no. This would look like the one I showed you in the beginning, where the sides are too short to even connect. Okay, and then the last one, Reese, does the last one work? Why not? Right, so what would it look like if I tried to make a triangle out of these? Straight line. It would be like this. I'd have 5, 7, they'd line up to 12, so that does not work. No. If you could summarize your notes and then get out your laptop, but we are not doing your assignment yet. We have a lot of time.